Okay, question 5. Now for this type of question, for me, it's imperative to do a decent sized diagram. So don't rely on the one that's on the exam paper. I suggest you doing a large version. We know this coming in with a direction 2, minus 3. So we know the direction of this one is, 2, minus 3. We're told the direction of the wall is minus 1, 3. We know the coefficient of restitution between this wall here is a half. So if this is 3, this is 2. This will be 2, and this will be 1.5. Okay, and we then know it bounces off here, and we're trying to find this one, V. Okay, so now I'm going to break this one down into its two components, which are right angles to the wall. So let's go for different colours. Go for blue, and a component this way. Alright, now I know, remember these are velocities, these aren't lengths, so be a little bit careful. So if this is 2, 1.5, then I know the magnitude of this vector here is square root of 2 squared. So this is root 6.25, actually it's 2.5, isn't it? So 2 squared, okay, which does equal 2.5. Okay, so now I am interested in this angle here, because I can do 2.5 times sine and 2.5 times cos if I need to. The cos one is probably easiest. I know the normal vector to the plane, so I know this vector here. Oh, a bit faint. This is minus 1, 3. Turn it round and change the sign. This one's 3, 1. Well, this would be 3, 1 if I carried in that direction. So I'm going back this direction, would be minus 3, minus 1, wouldn't it? Okay. So 3, 1 in that direction, going backwards. Sorry, 3, 1 that way, minus 1. Minus 3, minus 1 that way. Okay, so I now know the direction of this one. So I can find this angle here is the same as this angle here. And to get the blue line, that line is 2.5 cos alpha. Okay, and if I do the dot product, so I know, what do I know? I know this direction and I know this direction. Okay, so if I make them both come away from here, that way and that way, I know that minus 3, minus 1 dotted, this is 2, 1.5, so going the other way would be minus 2, minus 1.5 equals the magnitude of this one, which is root 10, times the magnitude of this one, which is times 2.5, times cos alpha. Okay, and this is what I want, this bit here. So therefore, dot product is 6, 7.5. I've gone wrong here on that. So we get 7.5 over root 10 equals 2.5 cos alpha. So I now have this one. I'll call it A. So I've got A. That immediately tells me that B, which is up here, so that tells me that B equals, because the coefficient of restitution with this wall is a third, B will be a third of A, so it would be 2.5 over root 10. Right, now I want to find this one here, length here, and that is 2.5 times cos theta. So this one here, 2.5 cos theta. And to find theta, I need, it's the angle between the wall and this one here. So I've got, I'll make them both go away from it again, so I get the right angle. So going backwards, I've got minus 2 minus 1.5, which is this vector here. Then this vector here is going to be 1 minus 3. Okay, equals, again, root 10 times 2.5 cos theta. And it's 2.5 cos theta I actually want. So this is minus 2 plus 4.5. So we get 2.5. Oh, sorry, what's happened to the focus? There we go. Sorry about that. 2.5 over root 10 equals 2.5 cos theta. So that tells me that C, which equals D, equals 2.5 over root 10. Okay, and what have we got now? So I'm trying to find V at the end. So what I've actually got, I've got a component in this direction. So I've got 2.5 root 10 in the direction minus 1, 3. And I've got equally 2.5 over root 10 in the direction minus 3 minus 1. Okay, so the magnitude of this vector is root 10, and I want 2.5 root 10. Okay, so this is root 10, and I want 2.5 over root 10. So therefore, for both of these, so this one I've got 2.5 over root 10 times 1 over root 10 times minus 1, 3. So by dividing by root 10, I've made that the unit vector, and that's the magnitude I want. So that's got a magnitude of 1, because that's root 10 over root 10, and it's got a direction, and I want to multiply by that one. Similarly, this one over here is 2.5 over root 10, again 1 over root 10 times minus 3 minus 1. Okay, and then I've got, this is 0.25, so 0.25 times minus I plus 3j is that one, and this one is similarly 0.25 times minus 3i minus j. And I want to add them together for V, so V equals and V equals minus 3/4 I. Oops, the bottom again. Minus 3/4 I minus 1/4 J minus 1/4 I plus 3/4 J, which equals minus I plus 1/2 J.